Hi guys. So I know you've all been looking for the video. Well, it's finally here. Just a minute. My light must be weird. Okay. Looks like the light keeps going in and out. I don't know what's going on. But the point is, I'm still here. I know everything's kind of getting kind of weird and scary. News this morning was not good. But just to know, I'm always here. I'm here for you. That doesn't change. Okay? We got this. So, we're still going to do chemistry. It's just we have to do it a little different way. And instead of all of us doing labs, I'm going to do them for you. Which is good because then, you know, like when we're doing labs, I can't get around to every group and say, okay, now watch this. Okay, do this. Okay, now I can do that. So we're going to just do the best we can. Okay, so today we're going to work on that lab that is in your textbook, page 232 to like page 236. Evaluating systems in chemical reactions. So we've already talked about chemical reactions. We know that a chemical reaction involves two or more substances changing into two or more different substances. So you got your reactants yield the products. And according to the law of conservation of mass, mass is always conserved. So what we're going to do today is we're going to do two different parts of this lab. The first one is going to be in an open system, and we're going to see, hopefully, that the mass changes. And then in the second part, we're going to do a closed system, so hopefully we're going to see that the mass doesn't change. All right, so I'm just going to jump in and show you the first part. The first part is to burn some magnesium. Wait, can't find my magnesium. Where did it go? All right, had to get a new piece. It's probably laying on the floor on the other side of the table here. All right, so I've got some magnesium, and it's all black because it is oxidized. That's okay. It will work just fine. So I'm going to put this into my crucible, and okay, so it looks like that. And I'm going to mass it. Now, I've already got the masses in a data table put on a sheet, put on my smartboard along with some parts of this lab just to get you so you know where I am with everything. So I'll post that along with this video. So you have to open that document up and look at the masses. They're all already written down for you. Well, they're going to be. Okay, so, all right, got my reactants. I have to write these down. Hang on. Okay. And now I'm going to burn my magnesium. Oh, look at that. I got new gas jets. Okay. So, I'm going to get it started so that you can see it here first. There we go. And then I'm going to drop it into the, okay, whoops, dang it. Okay, so you could see bright light. Can you see this gas? There's a gas giving off, bright light, still going there. I got it all in here, but it's an open system. There's no lid here. And you saw gas going away. So what should my mass do? That bright light, what is that? Energy? Yep. All right, now I have to let this cool a little bit because it's really It's really hot on the bottom. I'll let that cool, and then I'm going to mass it again. But you saw the main part. So I have a mass before. When I burned it, you saw a bright, bright light. You saw gas giving off. And let me show you now because it's still kind of hot. You see in there? It's turned white, so it's not the same color as it was before. All right, so while that one's cooling, before I can get another mass, I'm going to show you the one in the closed system. Now, so I took a Ziploc bag and I masked it. I have 20 milliliters of water, and because the density of water is 1 gram per mil, that would be 20 grams. I have 2 grams of calcium chloride, and I have 2 grams of sodium hydrogen carbonate, baking soda. All right, so now I'm going to put them together. Actually, I'm going to put one of the solids in one corner of the Ziploc, the other solid in the other corner of the Ziploc. And I don't want to fill it with a lot of air. Let me see if I can get this up here. Now you can see it, okay? Come back. There we go. I don't want to get it filled with a lot of air because I don't want that to affect my mass. So now I'm going to pour in the water, and I'm going to pour in the water so that it stays kind of in a pouch down here so stuff isn't mixing together until I get it all together and sealed without letting in very much air. And now I'm going to lift it up and roll over the top first so that the water and the solids mix together. And can you see what's happening there? Can you hear it? Okay, it's producing a gas. I want to fold it over as many times as I can so I don't lose the gas. Okay, you can see that the bag is filling up. And the solution down here where the reaction is happening, it's really cold. Okay. So my bag, hopefully I don't pop it, is just about full of gas. The reaction is just about done. Okay, can you see? The bag is full of gas. The solution is white now. You can tell it's not like just dissolved, because if it was just dissolved, it would be clear, right? Like when you put salt, sodium chloride in water, it's still clear. So this is white. So it's actually a color change, a gas formed, and it got cold. All right, now I'm gonna put this little thing on here on the balance and zero it. And I'm gonna put my bag in, and I will, on the document that I put online, I will put all of those masses of my reactants, and we're gonna add those up. And then here's my products after the reaction is done. And the mass of this should be pretty darn close to the mass of the reactants. Okay? All right, so let's get that. Okay, it flips between 12 and 13. All right, so I'm gonna put this on that form, and I'll get this video out to you guys right now. It's about 10 minutes, so it should be good. And I miss you. Bye. Hey, keep doing chemistry. So finish this lab, including like you have to do a diagram, you have to do CERs. Finish the lab, and we'll check it sometime. Bye.